So how would you start him if he is a parallelogram?
It's a parallelogram if and only if.
A shape is a parallelogram if and only if it is a, who's above parallelogram? Can you think of that family tree? What was above him? I said the rest of the chapter is going to talk about quadrilateral. With two sets of parallel sides. So perfect with both of you saying if and only if and quadrilateral. So a parallelogram to me looks like a rectangle that someone shoved a little bit. In geometry, we don't say that it's tilted. We say that the figure is not standing straight up. It is slanted, or do you know the mathematical term for slanted? Do you know what the muscles are on the side? Oblique. So that's what geometry calls when a figure is just sort of tilted. Does that make sense? So we call this in geometry oblique. We have a quadrilateral, so how many sides? With two sets. So these two sides are parallel. And then these two sides are parallel. So two sets of parallel sides. Good enough? To name him, I'm going to put some letters on the vertex points, A, B, C, D. To name him, you write the word parallelogram. And you randomly pick a vertex, and it doesn't matter where you start. So I'm just going to pick C. And you can go in a clockwise position or a counterclockwise position to name him. So if you go counterclockwise, it would be C, B, A, D. If you went clockwise, it would C, D, A, B. So you need to write the word parallelogram in front. Which one?
Does it matter what letter you start with?
No, you can start with anything you want, which is kind of nice. I think most people start with the alphabet and do alphabetical, but it would not be wrong if you started with any other letter. You just can't start, like if you started with D, I don't want you jumping to B and then C and then A. And then so many people are going to get tired of writing parallelogram because it's kind of long. So we just draw the parallelogram symbol if you don't want to write out the word. So you have a couple choices to write out the word or the symbol. And then you can choose any letter that you start. And so likewise, going backwards, if they told you to write parallelogram X, Y, Z, F, something like that, then you draw a parallelogram and you can put X anywhere you want. I'll just start here. And then now I have a choice to go clockwise or I have a choice to go counterclockwise. I just can't go X, Y, Z, and F just in random order. So I'll just go X, Y, and then Z, and then F. How's naming a parallelogram? Sound good? What's his definition? He's a quadrilateral, four sides with two sets of parallel sides. Okay, so now he's got some characteristics. Sound good? He has the most. He has the most. Okay, who is under parallelogram? Do you remember? You gave me some other choices. Who is in that middle parallelogram family? Rectangle, rhombus, trapezoids and kites are the loners. They're way over here. So rectangle, rhombus, and square. So they're underneath the parallelogram in that flow chart we had. So the hard part is everything underneath in a family tree. So you have your grandma, right? Or your mom. And then they have 2 kids and so forth. So if this is Sarah and Bob or whatever, doesn't Sarah have characteristics of mom and doesn't Bob have characteristics of mom? May not have every characteristic, but in the math world, everything, that rectangle, that rhombus, and square are going to have all these characteristics of the parallelogram. So when you think about all the characteristics, you're naming like a heck of a lot, okay? So characteristic number 1. Opposite sides are congruent. Opposite sides are congruent. Okay, so we draw a parallelogram. Ooh, how does that look? Does he look good for a parallelogram? No, why is he not a parallelogram? He's oblique, sorta, yeah, kinda, but he's missing. You got it. So I write him kind of small because I don't want him in the way of all my characteristics. But if the parallel arrows are not there, then he is not a parallelogram. Okay, opposite sides are congruent. So we have 1 tick and 1 tick, and then 2 ticks and 2 ticks. Opposite sides are congruent. Good? That one's a nice characteristic, easy characteristic, not bad. Characteristic number 2. Opposite angles are congruent. So we'll draw another parallelogram. What do we have to put in? Arrows, right? Okay, opposite angles are congruent. So we're going to put arcs in the corners that match. So this angle is going to be congruent to the opposite angle. And then likewise, 2 arcs and 2 arcs. How's opposite angles congruent? Okay, number 3. Start with a parallelogram. And the characteristic says consecutive angles are supplementary. Consecutive angles are supplementary. Okay, consecutive is right next door. So if you think about your house, sometimes you have a neighbor to the left and sometimes you have a neighbor to the right. Agree? So if I'm consecutive maybe to the north, it's this family. If I'm consecutive to the south, you're this family. So if I number them 1, 2, 3, and 4 for the 4 interior angles, that add to from section 6.1 what? Add to 360. All triangles add to 180. All 4-sided add to 360 every time. Okay, so everybody, let's just pick a random angle, and we're going to pick angle 3. So if we pick angle 3, who is consecutive, let's say, quote, to the north? Who would that be? 2. So the measure of angle 3 plus the measure of angle 2 is 180 because we know that supplementary means 180. But if we're at 3, go consecutive the other way, and who's its neighbor? 4. So the measure of angle 3 plus the measure of angle 4 is equal to 180. What if I randomly picked angle 4? Who would be consecutive to 4? 1 and 3. So it doesn't matter where you start, you just got to go in both directions. So if you think about it, I like to look at it this way. Both ways. Both ways. How's the third characteristic? Good? Okay. The fourth characteristic. Let's draw a the diagonal one. Draw the arrows in for parallel. I'm going to label these A, B, C, and D again. Do you remember from the very beginning of this chapter what a diagonal was? So if I start at vertex B, who or where can I draw a diagonal to from vertex B? To D. Why only to D? Diagonals can only be drawn to non-consecutive vertices, not next door neighbors. Does that make sense? So we got one big diagonal there. What if I was coming from A? Where could I draw from A? C. What if I was coming from D? B. And what if I was coming from C? Okay, so this is all the diagonals I can draw in the whole shape. Agree? Okay, so this one says the diagonals are bisected. If I'm bisected, I am cut into what's bi? To two congruent pieces. So this diagonal is cut into two congruent pieces, and then this diagonal is cut into two congruent pieces. This gets confusing later because it does not mean that the whole diagonal length is congruent to the whole diagonal length. If this is 10, this is 10. If this is 5, this is 5. The whole lengths are not congruent. Just the actual diagonal is bisected. Good? Okay, if I was writing my own textbook someday, I'm going to add a fifth but put an asterisk by it because it's not in your book, but I think it's sort of a duh one. That they think that you already know it, but I think it'd be fun to put on our sheet. So let's draw a parallelogram. And I'm going to just put the one diagonal in. And just from this picture alone, you've seen this picture. We did a heck of a lot with chapter 4 in proof, so Lauren's got it. What is it? Yeah, we got two congruent triangles, absolutely, because opposite sides are congruent. So we have a side congruent to a side congruent to a side, and a reflexive side, so SSS, that's beautiful. That was really good. What else do you notice? Go back even to chapter before that. Okay, these marks are huge. What does this mean? Okay, so what if I just drew that to the side? I just drew the top and the bottom, and then put that diagonal in. What does that look like? Two parallel lines cut by a... Okay, so what do we know about angle 1 and angle 2? Alternate. Yeah, they are the same. They're totally congruent. They're called alternate interior. And what about 3 and 4? Okay, so I'm going to do an arc for 1 and 2, and I'm going to do 2 arcs for 3 and 4. And then draw the other diagonal in. Let's do 5, 6, 7, 8. Who's congruent over there? 5 and 7 match. What am I up to? 3? And then 6 and 8. 4? That's a lot. What do you want to call him? I just did this underneath. And then I remembered it. 2 parallel lines cut by a transversal. You could always do alternate interior angles, congruent, give yourself a little note. Again, you're not going to find it in the book, but it's going to be helpful to use as a property. Does that make sense? Because doesn't it come from 2 parallel lines? I think it should be a property. All right, you ready to look at some problems, what we're going to do with it? How many characteristics technically? 4. I'm going to add one more later when we get to it, but I think we're good with these 4, right? Maybe the 5th? Okay, so let's look at some problems and see how you do. If I ever asked you to list the characteristics, then if you listed that 5th one as a characteristic, that would be great. I would never take off. But if you didn't draw him in, I can't take off because he's really not a characteristic. Does that make sense? Okay. All right, so there we go. So what do these problems look like? We'll do just a few of them. Okay, so I cut off the directions because I enlarged it so much. But at the top he says he is a parallelogram, right? So if he is a parallelogram, as long as he says that, then we're fine. But what's missing in this picture are the what? The arrows, right? But since he is in the directions to say to ensure that each quadrilateral is a parallelogram, what do we know about these 3 positions and what are we going to do? To solve for x or solve for y? Tess, what would you like?
60 is equal to 5y.
To 5y, because what property allowed you to do that? Opposite what?
Opposite equals 0.
Yeah, totally great. 5y equals 60, y is 12. That's nice. Okay, now what? She's got the y beautifully. What's going to happen with the x? Want to keep going?
Yeah, then you do 12 plus 3x plus 60 is equal to 180.
Almost.
Or no, you have to do, because it's 5y. So
Yeah.
you just do 60.
Yeah. So you can look this way, and those 2 are consecutive neighbors, right? Or you can look this way. Either way, she's totally right. Stick that 12 in there, and you get 60, and so you get 3x plus 60 equals 180, because they're not congruent, they're supplementary. 3x plus 120 equals 180. What are you going to do next? Subtract the 120. What do we get? 60, everybody? And x is 20. How's that one? Okay, so 2 properties were used. Opposite angles are congruent, and what's the other one? Consecutive angles are supplementary. Excellent. Okay, a couple more. Okay, let's do, I like this one. 33. Okay, are these angles? What are they? Okay, so I don't have a degree bubble for sure, so you know that they're not angles, right? And so if you look at your properties, it's an easy one. Opposite sides are congruent. So you would set 4x plus y equal to who, everybody? 8. And you're like, okay, I can't do a darn thing. Can't solve for x, can't solve for y. So let's go the other one. What about these 2? 2x plus y equals what, everybody? 6. Huh. What do you do when you have 2 equations, 2 unknowns from your favorite algebra days? Yeah, solve the system. I think I would just simply subtract at this point. Because what happens if you subtract going down? What happens to the y's? They're totally gone. What is 4x minus 2x? Y minus y drops out. 8 minus 6 is? X is? Nice job. How am I going to get y now, though? Plug it in. Does it matter which one you plug it in to? I'm assuming you're just going to go to this one. 2 times 1 is 2. Plus y equals 6. Y is a simple 4. So you use the property that opposite sides are congruent, and then they snuck in your favorite algebra to solve the system. 37. Okay, what property do you see first? And because it doesn't matter sometimes which one you see. The sides are congruent. Okay, opposite sides are congruent. So we have 2x plus 2y, everybody what? Equals 26. If you want to put tick marks, great. No big deal. That doesn't get me anywhere. I can't do a darn thing. So I look at another property. Now these have degree bubbles. So you have to decide, ooh, are they opposite angles? No, but it's that one weird property that I sort of added. What are these to each other? Because if this is a parallelogram, they're parallel. Yeah, they're alternate interior. So x plus 5y equals 53. Okay, so I can't just subtract or add going straight down because nothing drops out. So I think I would do elimination method. I might multiply this bottom equation by -2. And so the top equation will stay exactly the same. You get a -2x. What do you get here? Negative what? 10y. And 53 times 2 is -10 what? 6. Awesome. Now, when the signs are opposite, I don't subtract. Like the previous one, the signs were the same, so I subtracted. So when I have signs that are opposite, I can just what then? Add? Okay, what happens to the x's? Okay, what do I get for the y's? -8y? Okay, and then what happens with the 26 and the -106? -80? And then y simply is? Okay. One more? Okay, property opposite sides are congruent, and my own made up property of alternate interior. Okay. Last one. I see nothing about the sides. I see nothing about the angles. There's no degree bubbles. So you look, and these are associated with parts of the diagonal. So the property says the diagonal is, what's a diagonal? What's the word they use? Bisected, which means each diagonal is cut into bi, meaning two, so each piece. And you see how this one's already cut into two congruent pieces, nothing to do. But that means the other diagonal needs to be cut, so the simple equation would be what? You got it. 3x squared equals 48. To solve for x, we're going to do what? Divide by 3. So you get x squared is equal to 16. Take what? Square root. I saw you write it. Good job. And then you get what? You get what? Nope.
2.
Nope. Keep going. Plus or minus 4. Plus or minus 4. So 2 answers is fabulous. Okay, let's go do a little algebra review. You ready? X plus 2 equals 7. What would you do your first few days of algebra when you solve these equations? You would subtract 2, and x is equal to? Okay, you got one answer because your exponent is 1. That tells you how many answers there'll be. So when you start off with 3x squared equals 48, your highest exponent in the problem tells you how many answers you have. So you should have 2. Now they may not work because it's associated with a picture, but you should have 2 answers, so we got to check it. The positive 4, no problem. How about the negative 4? If you take negative 4 and you square it, what do you get? You still get positive 16 times 3 is 48. So 2 answers. You'd miss 1 if you forgot the negative. Okay, how's that? Is that a good review? Okay, so your homework is already on Google Classroom as a worksheet.